Hi all, hi. Previous sessions I promised I will go through what is the vectors equation of a straight line because from experience I realized that many students are not, they know it's like, a point on a line and a lambda, a scalar of a directional vector parallel to the straight line, but they don't understand what that it really means. So what I'm going to do is I'm going to explain to you what the vectors equation of a straight line really means. Okay, so we have this. Let me just get my pen. Okay, all right, so let's say this is the origin, and then we have point A. Point A, let's say is 1, 2, 3. Okay, and then this vector is parallel to say 2, 1, 5. Okay, then the vector equation of this line would be the point on the line plus a scalar. Let's say I put it as lambda of the vector parallel to this line. But what does this mean? This is something that many students know how to form the equation on line but don't really understand what it means. Okay, let me explain what it means. Okay, let's say I have a point B here. Okay, this is my point B. In order to get to B, right, I need to first go to A, then travel a distance along this parallel vector 2, 1, 5 to go to B. So let's say OB is equals to, I need to first get to A, right? So OA, this one would be my OA, okay, plus lambda of, so let's say in order to get to B, the lambda is 1, okay? The lambda is 1, so 2, 1, 5. So which means OB would be, if you work it out, you get 2, 3, 8. 2, 3, 8. It's very close to the edge. But anyways, this is not really important. What is important is this one, right? Okay. So say I have OC. I have C, point C on this line. Okay. So in order to get to C, I need to first get to A, OA, plus, let's say I need to travel twice the distance, so 2. Lambda here is 2. So let me just remove this first, yeah. Okay. 2, 1, 5. Okay, and then you can work out what this is. Okay. Let's say now I have my D. Okay. So in order to go to D, my OD would be equals, I first have to get to A, OA. But this case is an opposite direction of 2, 1, 5. So it will be minus 2, minus 1 and minus 5. So it will be minus 1. Okay, let me just write this origin somewhere else. Okay, this is my origin. Okay, so minus 1 of 2, 1, 5. So from here you can see that all you need to do is to vary the, hold on, how can I get this? So all you need to do is to vary this lambda, right? So OB is lambda 1, OC 2, and OD is the opposite direction, so it's minus 1. Okay, so obviously if you have a, say, E, right, so basically my OE would be 1, 2, 3, I will say probably minus 2 of 2, 1, 5. Right. Okay. Alright, so this is minus 2. Let me just minus 2 here, okay? So in a nutshell, right, the vectors equation of a straight line is simply the vector of every single point on the line, okay? So by varying this lambda, right, so every point on the line has a different lambda, have a different scalar. So this simply means, is simply the vector of every point on the line by varying lambda. So this will give you more insight on what the vector equation of a straight line really means. Okay, by the way, let me just share something with you. Let me just go to the next screen. Okay, I am conducting 4 vectors crash course plus 1 vectors mock exam. This mock exam is very useful because it will contain all possible types of vectors exam questions. So far I have recorded 4 videos on vectors, but in the 4 videos I only went through the certain key points. There is definitely not everything about vectors. I haven't covered quite a lot in this video. So in the 4 vectors crash courses, I will cover every single concept, including the parametric interpretation of vectors, and the very importantly, this mock exam, right, is very, very useful because after covering the concepts and going through, in the course I will also go through even more challenging questions which I will show you an example of a very challenging question involving planes, which I will go through the solution and the concepts in the course. And also the mock exam will contain all possible vectors exam questions. So this is for people who aim to score absolute the top grade in A levels. Because vectors made up a big portion of the marks typically. So by being able to solve all the vectors questions, you can be assured that you're on top of the bell curve, and therefore you can score any better grades and have a advantage over your peers. What you can do is you can email, I'll just email me at faith, F-A-I-T-H, tutor 186 at gmail.com. Register your interest. I will let you know the slots available and the payment methods. And the course is very, very worth it. It's for, you will get notes, you will get the mock exams, and then I will even mark you can send me your workings, your answers, I'll mark for you, and I will guide you on where you've gone wrong, and should even provide you with the model answers and the steps. Okay, so email me. Let me just write my email. Tutor186 at gmail.com. And I also mentioned that in the course, I will go through this very challenging question, which is, so far we've gone through planes and distance between two planes, where the planes are equivalent distance. Like one plane here, we have a plane that is like, say, 9 units from this center plane, and we want to find the equation of the two planes here and here, which are 9 units away from the center plane. So those we have gone through previously in the video, but there's one very, very challenging one which involves even higher level of technique, which is like that. So you have two planes which intersect each other. Okay, these two planes intersect each other, and you are given the equation of these two planes, say r dot 3, 1, 2 is equals to 5, and then you are given the equation of this next plane, say r dot 5, 2, 3 is equals to, say, 3. Okay, so then there's this particular point which is equidistant from these two planes. For example, you have a point, say, P, which is equidistant from this plane and this plane. Okay, let's say the point is 6 C1, for example. Okay, C is the ABCC, the algebra. Okay, so there's this point P that's equidistant from these planes. But take note, the question say point P is equidistant. How many values of C is unknown? How many values of C do you think the answer would have? For those who said 2, you are very smart. C has 2 answers. Why? Because the point P can be here as well. When the question says equidistant from the plane, it can be equidistant from the top of the two planes. It can also be equidistant from the bottom of the two planes, right? So basically, you could also have 6C1. Therefore, you have two answers for C. Then, this one is you need higher level. Even you need to put on even bigger thinking cap to solve this. Because now you're not talking about the distance between these two planes. You're talking about a point which is equidistant from the two planes. And you want to find the unknown C for this point. So you are still working from back to front, but it involves a more complicated technique. Okay, so these are the things that I will go through in a crash courses. I will go through very challenging questions, exactly what concepts to apply, and how to go about this. So at the end of it, you will basically be a vectors expert, and you should be able to answer all kinds of exam questions involving vectors, and the mock exam will further reinforce that, because you'll be able to apply this in the mock exams, and I will mark for you and I'll provide further guidance. Okay, so don't forget to email me and I'll send you more details of the course, okay, and the dates and the slots available. Okay, all right. Okay then, so I will reply to your emails. Okay, bye bye, take care.